Rationalizing denominators. So given something like 8 over square root of 13, in math, just kind of out of formality, we don't really like to have square roots in the denominators, so we have an option to get rid of them. What we do is we times the top and the bottom by that denominator. So square root of 13 times square root of 13 becomes 13, the square root goes away, and 8 times square root of 13 is just 8 root 13. So this is the same thing as this, but it has the denominator rationalized, so there's no square root in it. So 9 square roots of 7 over square root of 3, we would times top and bottom by square root of 3. So our denominator would just become 3. Square root of 7 times square root of 3 becomes square root of 21. And 9 divided by 3 reduces to 3, so I get 3 square roots of 21. Negative 10 over square root of 20 times top and bottom by square root of 20. So I get negative 10 root 20 over 20. They reduce, so I get negative square root of 20 over 2. Negative square root of 27 over 80. Remember the fraction splits. Also remember that these can be simplified. So I have negative 3 root 3 over 4 square roots of 5. So I don't want the square root of 5 down there, so I'm going to times top and bottom by square root of 5. So on top I get negative 3 square roots of 3 times 5 makes 15. 5 times 5, the square roots cancel, so 5 comes out, but it's got to times to this 4 out front. So 5 times 4 makes 20. Does this simplify any further? No, these two things don't reduce. So then we get something like this. Square root of 48x to the 8th all over y to the 6th. No, y to the 3rd. Sorry. So then, if I square root the top and the bottom, I get 4 x to the 4th square root of 3 all over y square root of y. Well, then this becomes times by square root of y to top and bottom to rationalize. 4x to the 4th square root of 3y all over y squared, because these y's will bring another one out and times to the one that's already outside of the square root. Cube root of 8 over 81. Well, that's 2 over. This becomes 3, 3, 3, and 3, so that's 3 cube root of 3. Because you have 3 3's but 1 left over. So here's the interesting thing. With a cube root, we can't just times by one more of them, because to get rid of this, we need 3 things for 1 to come out. So we're going to times by the cube root of 3 squared, because we need 2 more 3's down there to make 3 of them inside. So I have 2 cube root of 9 all over. So now these have 3 of them, so another 3 comes out, and 3 times 3 makes 9. Fourth root of 7x over y, assuming both x and y are positive. or 0. And y, well, assuming x can be 0, but y cannot. So first off, we have 4th root of 7x over the 4th root of y. So that means to rationalize, we need 3 more y's in that denominator to make 4 total. So 1 can come out. So on top, it becomes 7xy cubed under the 4th root. And on bottom, I now have 4 y's, so one of them can come out.